now that we've solved systems of linear equations by elimination, let's look at some other examples. So previously we've learned how to solve systems when we see something like these, for example. So for the first example, remember when we eliminate, what we want to do is when we add the systems together, a variable should cancel out immediately. So in this first example, we have the negative y and the positive y. That becomes a 0y. And then the second example, we have negative 5x and positive 5x. So if we add these currently, the x's would disappear. And so then for this example, we'd have 3y equals 12. And so we only have one variable. And then for the first example, we would have 6x equals 30. Okay, so we're going to look at some other examples. So again, we still want to be able to see when we have the same terms with opposite coefficients. For example, the 5x and negative 5x, and then the y and then the negative y, or negative y and the positive y, for example. So the other examples we're going to see are when we don't see that immediately. So here we have negative 6x plus 5y equals 25 and negative 2x minus 4y equals 14. So currently, if I were to add these systems together, one variable would not eliminate. So let's just check it. So negative 6 minus 2 is negative 8x, and the next would be 5 minus 4y, which is a positive 1y. So we didn't eliminate a variable, but we want to be able to do that. So how can we make it happen? Well, let's take a look at the variables first. So we have x and then we have y. So looking at the x values, for example, we have negative 6x and negative 2x. We want it so that they're the same exact number but opposite terms, opposite signs. So 2 and 6, we see 2 and 6, and then we also see 5 and negative 4y. We can see that if we changed equation 2, so that way we could change this negative 2x to a positive 6x, all we'd have to do is to multiply this bottom equation by a negative 3. If I multiply this bottom equation by a negative 3, this is what happens. So I'm going to go ahead and I'm going to show this. So we're still distributing, but that's going to show at the bottom. So negative 3 times negative 2x is positive 6x. Negative 3 times negative 4y is positive 12y. And then 14 times negative 3. Let's do the work over here. 14 times 3 is 12, and then 3 plus 1 is 42. So negative 3 times 14 is negative 42. So that is equation 2. Now equation 1 we're going to leave the same. Equation 1 is negative 6x, this one here, plus 5y equals 25. Now if I look at this, now they will eliminate. So we can add these together now. 6x minus 6x, that becomes 0. So we eliminated the x value. Then 12 plus 5 is 17y. And then 42 minus 25, negative 42 plus 25, we would subtract that to 12, 3. So this is negative 17. And then we solve like we did before. We divide by 17. So y equals negative 1. So just like the other day, once we solve for one of the terms, we plug it into one of the equations in order to solve for the other variable. So y equals negative 1, and you can plug it into one of the original ones. I try to find the one that has the smaller terms, just so there are smaller numbers to deal with. So I'll plug it into equation 2. So negative 2x minus 4 times negative 1 times negative 1 equals 14. So we want to solve for x. So negative 2x plus 4 equals 14. Subtract 4 from both sides. So therefore I have negative 2x equals 10. And then divided by negative 2. And so x equals negative 5. So the solution to this system where they intersect is negative 5 comma negative 1. So that's the ordered pair. Now, of course, I should do a check and make sure this works. So let's do that. Let's do a check real quick. So our check. So we'll plug it into the first equation, negative 6x plus 5y equals 25. So negative 6 times our x value, which is negative 5, plus 5 times negative 1. Does that equal 25? So this is 30 minus 5. Does that equal 25? And yes, 25 equals 25. So that is true. Now let's check the other one. I'll go ahead and erase this one. And we'll check the other equation. Of course, you normally leave it there. I just need some more space. So we'll plug it into negative 2x minus 4y equals 14. So negative 2 times negative 5 minus 4 times negative 1, does that equal 14? So this is positive 10 plus 4 equals 14. And yes, this is true. 14 equals 14. And so this works. So this is another example of solving by elimination. We have to multiply one example. Go ahead and try this example here. And on the worksheet, you'll see the answer. And then I'll show you the answer in the next video.